Hello, this is Notion Marthy and I'm from Group 2. Here you can see a simple line following robot which has 4 wheels and 3 distance sensors pointing downwards. Also it has a camera but it's not being used right now. So this robot is mainly the same one I used in the first project except one thing, the sensors, which is very important. Well, let's look into some more detailings. Here under the robot and under children, you can see the most important files for building the robot. First of all, there's a solid, which is for the camera, which is not being used right now, as I said. Well, the second one, which is distance sensor, right. Oh, well, let's pause the simulation for a while and let's zoom into it. Click the distance sensor right, you can see the sensor here, the first sensor, the right sensor. Well, the very important thing is the name here, because the same name we'll be using in the code, so you'll have to remember the name and you'll have to use the same name here. Okay, here the translation for each sensor will be different, but the rotation will be same and the scale will also be same. Just because of the position, the translation will differ. Well, let's see the second one. You see the translation is different but other things is same. I'll just copy and paste. You'll have to make sure the rays are pointing downwards. You can see the rays are pointing downwards here. If your rays are not showing, then you can go to the view option rendering and click here. I've already clicked and my rays are being shown. The rays are being pointing downwards so that the robot can see the line under it and it can follow it accordingly. Let's move to the hinge joints. The hinge joints are mainly the wheels. Well, let's open the first hinge joint and under the device, you'll see the name. And again, the name is very important as you'll have to use the same name in the code. You'll have to remember it and you'll have to name it accordingly. The position, anchor, everything is different because of the positions of different positions of the wheel. Okay, well, let's go to the second hinge joint. You can see the name is different. It's right front and this is the left front, this is the left back and this is the right back. RF. Well, let's go to the diff body shape, which is mainly the robotic shape. I have used a rectangular body here. As you can see, you can use anything you want. So yeah, that was my robot.
Hello everyone, I'm Zoran Mishadabidin and now I'm going to talk about how we created the track of our robot. To design the track, we have to go to this website called Autodesk TinkerCad and create a new design. We will use this scribble to draw our track. According to the requirement, we have to draw 3 to 4 turns in our track, and which we have done. And now we will make the height of our track as low as possible. Here we have made it 0, and we will make the color black. Now we will export this file, download it and export it as OBJ file format. After exporting it, we will import the track in our environment. So after we have imported the object successfully, we will change the values of the axis, XYZ axis, and the angle to adjust the track in right position. We will try to place it on top of the plane, for which we need to change the scale of the track, and we need to adjust the axis. That's it. Thank you.
Hello everyone, I'm Aditya Bishwash. My ID is 18101015. I will be talking about the coding part of our project. So this is the code our robot will work on. First we have to integrate it with Webots. As we can see, we have some variables in this code. First of all, I imported the robot library here, then created an instance of robot. Here, this will give us the value of the sensors which we will be able to see at the console. In this part of the code, I have initialized the sensors. Here the device name needs to be the same as we declared the sensor name in Webots. We have used 4 wheels in our robot, 2 on the left and 2 on the right. We initialize these wheels here. Here also the device name needs to be the same as we declared the wheel's name in Webot. In this segment of the code, we will be processing the sensor data, and for this value here, we need to calibrate it from the sensor data. It depends on the reading of the sensor. As we can see from the console data, when the middle of the sensor is active, it is giving us a reading of around 390. That is why we made the threshold value 300. If the sensor is not on the line, then it gives value less than 300, but if it's on the line, it gives value more than 300. So for this condition, if the left and right sensor gives the value less than 300 and the middle sensor gives the value more than 300, all the wheels of the robot will go as max speed. Rest of the conditions are same as this one with slight changes. From these conditions, the robot understands when to go straight and when to go left or right. That's all. Thank you.
To wrap it up, we'll be taking a look at the simulation of the LFR. We hit play. Okay. So as we can see, it's running smoothly. The way this works is during making left turns, the left sensor and the middle sensor will give a high reading, whereas the right sensor will give a low reading. This difference causes the left motor to stop temporarily and the right motor to speed up temporarily. This causes the bot to make a left turn. Similarly, when making right turns, the right sensor and the middle sensor give a high reading, whereas the left sensor gives us a low reading. This causes the right motors to stop working and the left motors to speed up. This causes the bot to make a right turn. So if we pause right when it's about to make a right turn over here, we can see that the right and the middle sensors are at 391, a high value, and the left sensor is at a low value of 196. This causes the right motor to stop running and the left motors to speed up, hence making a right turn. Similarly, when making left turns, we should expect the left and the middle sensor to give a high reading, 392, and the right sensor a low reading. This causes a left turning of the robot. Thank you.